Okay, where are we in planet Earth? We've outlined the 6 layers. We've studied the 3 interior layers of the mantle. We looked at 4 ways that the crust and surface can change. I didn't mention water. You might think about that. Where did water come from? It's still being explored. So let me mention that real briefly here. That one thought is comets, which are big icebergs, get to that a little bit in chapter 9, could slam into Earth. We saw craters, etc. Maybe comets bring water, and lots of comets over the period of time can bring lots of water. Maybe as Earth formed, there was water, and that was part of what was already here in the area. Asteroids have water. Maybe there's another process, creating water. So I won't go into that too much, but you can explore and see that it's still being explored, and maybe some of each happened where we got our water. But it could very well be that when we drink water, we're drinking comet juice. Kind of cool. We've got our atmosphere to deal with, and that's longer. So let's take care of our magnetosphere, and there is a connection by doing it this way. There's a reason. So I'm going to go down here, and we're about to do our magnetosphere. I like to say magnetosphere, but magnetosphere is kind of neato. And we're going to talk about what's up with Earth's magnetism. Quick, 5 things you need to know. That's it. Just 5 things. Here you go. If I can do that for you. There we go. All right, a little better. Sorry. All right. 5 must know. Let's take a look here, though, first. Let's take a look here. Remember Earth. I'd kind of like to make that like a black iron cannonball. Solid, liquid, metal, rock, hot rock, convection, spinning Earth, spinning globe. Let's think about that. And let's think about magnetism. Okay? Let's think about that. Let's go back up to here and talk about it. All right. So what do you need to know? Quick and easy. We've talked about this. Where is it created? Well, it's created in which layer? Which layer? Deep inside. So it's created here in the liquid outer. This is the inner, that's the outer core. And so it starts there. All right, let's do it in purple because I don't know why. Well, starts here. Okay. What's it created from? It's created from the liquid iron and nickel, that I'll just leave it at that, liquid iron in that layer, and important, also Earth's spin. And Earth is spinning rather rapidly. Okay. Earth's spin. We'll talk about this here in a second. Let me do these 2 and then I'll show you something. And the thing is that you can measure this as it comes up from deep down inside. You can measure it at the surface, right? And how do you measure it at the surface? Well, we use a compass. And now, a lot of people have a compass on their phone. But it's not bad to bring a compass if you're exploring Yosemite or Yellowstone or Utah or Grand Canyon or any of the beautiful places that you can explore. So we use a compass. And what you find is that not only can you measure it at the surface, it's not just at the surface, it comes from way down inside, it goes out to the surface, but it extends way past our atmosphere. And that blue line is thicker in reality than our atmosphere would be for this. And so we've got this, and it kind of comes out here, and it comes out, and it goes like that. Don't worry about the arrows, I'm just being a little picky here. And it goes like that. So way out, I'll show you a picture or a graphic. You can look at them pretty easily. But know this, know where it comes from, know why we've got it. You can measure it at the surface, but it comes from way down deep inside, and it goes way past our atmosphere. That's a very, very, very good thing. It's a very good thing. Maybe I'll just recap and put this in here. Because it protects us from the solar wind, which we'll see again with our atmosphere. The solar wind. This is damaging high energy bits of matter. And they get deflected. And they spiral into our atmosphere, going through the gas of our atmosphere, usually near the poles, mostly near the poles. And so what does that look like? Now the solar wind is mostly electrons and protons, protons being damaged. So we'll just say mostly protons. You can look up more about that if you want, but mostly protons. But they're high energy, so they can be very damaging to live tissue. And so here they are streaming in, but wait, we've got a magnetic field. And the poles of magnetism aren't exactly the geographic poles. I'm not going to go into that here. But we're going to come out. Way out. And these bits of matter come in, and they tend to hit here, and they get deflected. The magnetism deflects these things, and they tend to start spiraling. They spiral. And they can spiral that way, or they can spiral in this way. And as they come in this way, when they pass through that thin atmosphere, something happens. But number one, remember that, number three. Number one is, where is it created and started and why? Number two is, well, where does it go? I mean, it comes from inside, but then there's the surface and out way past the surface. Why is that good? Because it protects us from this very damaging solar wind. I don't think trees are going to like that very much. So what would that do to our surface? Would our planet even be viable for life without that protection? Would life have to remain in the ocean? So there is interesting, all this interplay, space is not a very friendly place. You need to protect, you can protect against that stuff. We know how to do that, it's not a problem, but just floating in space, not so comfortable. So it protects us from the solar wind, damaging hundreds of bits. We can see what happens. And as it spirals through into our atmosphere, and I'm going to show it to you, the gas glows, the gas of our atmosphere, the oxygen and nitrogen of our atmosphere. And so that gives aurora, usually near the poles in this region, Arctic and Antarctic. You see it a lot. Those are pretty lights. I'll show it to you here. Green, violet, red, related to the atoms in our atmosphere, molecules in our atmosphere. In the northern hemisphere, these are sometimes called the northern lights, or Aurora borealis, that's in the book, or the southern lights, or Aurora australis. They're beautiful. If you haven't seen them, it's on your bucket list. It's gorgeous. And when you know what's going on, it's just that much cooler. So I encourage you to do that. So where it comes from, measured at the surface by us with our compass, that's what you're measuring, something from deep down inside. And it goes way out, protecting us from our solar wind. It has changed. We talk about North Pole and South Pole of a magnet, and it is in the process of changing. And you can look that up. Now, some people say, well, if we don't have that protection, we're all going to die. Well, it has changed, and life was around in this last change, and so life survived. Now, does it cause problems? Would we have more aurora here and make it harder to see the stars? I mean, I like the aurora, but I want to see the stars. So, you know, I have a feeling I'm not going to be around that long to see what happens there, unless science brings me to a Neptune year, but we'll see about that. Okay, cool. So these are the 5 things. 1, 2, 3, 4, 5. It has changed. It is changing. Interesting. And I'll let you look at that more. Let's take a little look at some stuff here. I'll show you. All right. It's what's inside, and it's the spin. And there, of course, is a magnet. The magnets are fun. It's almost like magic. Some materials can be affected by magnetism. Ooh, good. Not even touching it is being pulled. And then it can be pulled. Look. It's weird. Pulled to the other side. It's a magic trick. What about aluminum? No. Aluminum doesn't play the magnet game. What about rock? Some rock, it's got iron in it, right? Some magnetite, some stuff. And not other stuff. What about leather? No, but when keys will do it. Oh, help it didn't mess that guy up. Got to be careful around those things with credit cards, etc. What about paper? We could explore, and a lot of exploration was done in the 1800s to understand that. What about a compass? Compass, well, it's cool. One side of the compass likes that side of the magnet, the blue side, and the gray side, well, the gray side likes that side. And magnets, actually, the physics of a magnet it's easiest to see, but it's complex about why that's going on. So it's kind of a crazy bit there. Let's take a little peek at some northern lights, and then let's make some real quick. That's it. That's all you have to know. But you know, it is pretty neat. You can see these pictures, and this, of course, is a crazy scale here, but good enough. Gets you the idea, and you can explore those pictures. It's important that we have it. And it may be important for a place for life to thrive. As it goes through near the poles, it makes the gas glow. Greens, and you can tell that this is sort of faked. Not the Aurora, but then you've got pictures of stars here or whatever. I mean, what is exactly is that? Maybe I'm wrong, but there's something funny about that. Anyway, beautiful. See the snow here. Just gorgeous. Again, so worth seeing. Reds, greens, violets, igloos. Credit to Rolf Ficker. Right around the North and South Poles in the Arctic and Antarctic that comes in. So what is that? It's particles sent by the sun, deflected by our magnetosphere that started deep down inside, goes way out, protecting us, going through, and giving what? Galapagos Island. What better image than the Galapagos to remind us that we live on a fantastically connected, wonderful planet we wouldn't live anywhere else, because if we're living, then it's got to be a good place, because otherwise life wouldn't be there. All the layers, just look at Earth, think about life and evolution of life taking a much shorter time, but thinking about all the connections from inside out, with the atmosphere very thin, which we talk about next, with the magnetosphere going way out and protecting us so that life can thrive. Now I have a little treat for you, and that is this. I'm going to make, and this is an important idea, I'm going to make Aurora. Okay. What is Aurora? It's an important idea when we study stars too. So like Earth is connected, so are these topics. And I've sequenced them that way. Okay. Here's our atmosphere under lower pressure atmosphere tubes. And I'm going to make some particles go through them. In particular, what I'm going to make go through them is electrons. So I'm going to send some electrons through them. Let's see if I can cut this real quick. Coming back. There we go. Now what does it look like for you? Not much. Good. Okay. Watch this. Here we go. I am going to make Aurora. You can see look at that. The electrons are going through the atmosphere. Right near the thing, it's making the atmosphere glow right near the tip as it sends out electrons. And then it goes through the tube and whoa! The mad scientist. And as those high energy particles go through the gas flows. And different gases flow different colors. And boy, that's a big clue we use to understand stars. So for now, we can feel like we're protected by a blanket of atmosphere and a blanket, a huge, thick blanket of magnetosphere. And besides which, it is quite beautiful indeed. And so we have our protective layer. You got that. Now we'll go on to the little more complicated atmosphere. How did we get it? What does a world need to have an atmosphere? And how did we get our atmosphere? Some basic, kind of simple steps. This is certainly not a full discussion of that, but just to get a sense of how that might happen. And then what are the current 4 layers and what's happening in each to protect us. So cheers to that.